All right, so let's focus on plate tectonics today. So on your notes, in the top section, you're going to see the essentials question section. Go ahead and fill in the essential question. What forces cause the continents and oceans of the Earth to change in shape and size? In the top right-hand corner, you should see a section for vocabulary. Find the section for vocabulary, and we're going to talk about the lithosphere today. The lithosphere is the solid crust and upper mantle for the Earth's interior. You are currently standing on the lithosphere. The lithosphere is the top outermost crust of the Earth. So then what are tectonic plates? All right, tectonic plates, don't forget to fill in your topic question that's over on the left-hand side. Your topic question is, what are tectonic plates? So the Earth's lithosphere is broken up into pieces that fit together like a jigsaw puzzle and are in constant motion. These pieces are called tectonic plates. There are 12 total tectonic plates. And those are the major ones. There's all the little ones that have gotten broken off and stuff like that, but the major ones are going to be those 12. The word tectonic means builder, and it describes the forces that shape the Earth's surface. Tectonic plate movement forms mountains, volcanoes, volcanic eruptions, earthquakes, ocean trenches, and rift valleys. So going on to topic question 2, don't forget to fill that in. So plate tectonics, or what is plate tectonics? Plate tectonics explains how and why the continents move and has become the unifying theory in geology. This theory states that Earth's surface is made of rigid plates that float on molten rock and move with respect to each other. Plate tectonics also answered a question that puzzled scientists about the process of seafloor spreading. When new oceanic crust is created, it spreads out and takes up space. Why does the generation of new crust not increase the size of the Earth? Why has the Earth not gotten bigger and bigger and bigger until it suddenly popped? So, moving on to topic question 3. Why do the tectonic plates move? Don't forget to fill that in. So they move because the superhot asthenosphere behaves like a plastic material. The term plastic in science refers to something that can be easily molded or change shape without breaking. So think of like Play-Doh, clay, fudge, okay? All of those things can move, and they move in this, they can slide past each other and such like that without breaking. And that's what we call plastic. And the asthenosphere is considered a plastic material because it doesn't break. So the molten rock moves, as we were talking about. So as it moves and flows, the lithosphere travels along on top of it. So it moves it around like a conveyor belt. So one of the ways I want you to think about it is think about like a bathtub that's full of bath toys with water underneath it. So as that water moves underneath the bath toys, the toys on top, they move with the water. And it's the same process with your tectonic plates. Is as the asthenosphere moves underneath, okay, it causes the lithosphere on top to move just like the bath toys. So the asthenosphere flows, and why on earth is the asthenosphere even moving at all? And that's because the asthenosphere is moving due to convection currents. So convection currents are the circulation of material caused by the differences of temperatures. So remember, the core is super, super hot, okay? Whereas the surface of the earth is not. So because there's that difference of temperature, it causes the warm or the superheated magma to rise. As it gets to the surface, it cools off and it sinks back down, and it causes this circular motion known as a convection current. So hot things rise, cool things sink. So material in the Earth's mantle gets heated by the Earth's core and rises. It then cools and sinks back down. That cycle repeats itself over and over and over. And so that's why the plates are constantly in motion. So go ahead and take a moment, color your diagram, label it, make sure you have your labels, and then we'll move on. So plate boundaries are where the tectonic plates meet. There are three ways that the two plates can move relative to one another. First of all, there's the transform boundary. The transform boundaries, the plates, they slide past each other. And the lithosphere is neither created nor destroyed. But what's interesting here is as they, let me get in shot, as they slide past each other, just like your hands getting stuck on your knuckles, they'll get stuck and hung up for a moment, and it builds a ton of pressure and friction. So as that happens, it suddenly releases. And you know what that sudden release is? That sudden release is an earthquake. So transform boundaries cause fault lines and earthquakes. So you have plate boundaries where the tectonic plates meet, or excuse me, I need to read it correctly. I keep hitting the wrong button. That's the problem. So at transform boundaries, you get friction and stress, which causes earthquakes. The one that we are most familiar with is the San Andreas fault line in California. And that is a transform boundary, and that's why we have so many earthquakes there. So then another type of boundary is a divergent boundary. When you think divergent, I want you to think divide, all right? DIV, DIV, okay? So as they divide, they spread apart. So at a divergent boundary, plates move away from one another. The magma fills from within, or the magma from within the earth, magma from within the earth fills that gap as they spread further apart. Now, the thing I want you to remember or think about with this is I want you to think of like a scab, okay? So if you have a scab on your elbow, scab on your knee, and it gets broken open a little bit, okay? You're going to have that blood and that fluid start to ooze upwards. Well, that's what's happening at a divergent boundary. You're going to end up with a section of magma, or there's some magma that will ooze upwards as that divergent boundary pulls apart. So as it pulls apart, the magma rises upwards, and it ends up creating this jagged scar all the way down the surface, or all the way down through, in our case, most of it, or the biggest one, happens in the Atlantic Ocean, okay? So in the Atlantic Ocean, it's steadily getting wider. It's getting bigger. The Atlantic Ocean is getting bigger, all right? So when this happens at plate boundaries in the ocean, the new magma creates new sea floor. The mid-Atlantic ridge and the East Pacific rise are mid-ocean ridges where sea floor spreading occurs. Now, it doesn't only happen in the ocean, though. Sometimes you'll have a divergent boundary on a continent, all right? And when that happens, you have what's known as a rift valley. So divergent boundaries in the middle of continents form rift valleys. The East African Rift is an example of a continental rift valley. So let's talk about what's happening there. So you have two plates, all right, and you'll have like soil and erosion and all sorts of stuff that's going to build up on top of these plates. You're going to have like huge, like thick sections of soil and dirt and just rocks and in general on top of this boundary. Well, as they separate, that rock and that soil and all that erosion falls downwards on top of where that magma is trying to seep upwards. So you don't really oftentimes have magma exposed, but you do have a depression that forms in the earth. Okay. And that depression, we see it as a valley, because you have to remember, this is all huge stuff that's happening. So you end up with one of the biggest ones is the East African Rift Valley. What's interesting about the East African Rift Valley is it's going to eventually join up with an ocean, more likely the Arabian Sea. And as that links up, it's going to end up creating a new ocean. There's a new ocean that's forming right now, but that is going to take, a few billion years for that to occur. All right. So, but I just want you to realize that all these things are happening right now. But there's a really cool spot in Iceland it's on my bucket list. I can't wait to go. In Iceland, Iceland is there because of the divergent boundary. The island itself has formed because as the plates spread apart, magma has come upwards and created Iceland. All right. But what's really interesting is there's a spot in Iceland known as the Silfra Fissure that you can touch North America and Europe at the same time. And that's just amazing. So, Iceland sits atop a divergent plate boundary between the North American and Eurasian plate. You can go scuba diving in the rift called the Silfra Fissure. All right, so then there's another type. There's the convergent boundaries. So if divergent means that they are dividing, convergent means that they are coming together. So at convergent boundaries, plates move towards each other and collide. So when you have two plates that collide, oftentimes one of them is going to go underneath, and that causes a subduction zone. A subduction zone is where one plate is more dense than the other. The dense plate sinks underneath the less dense plate in a process called subduction. Subduction comes from the Latin root subductus, meaning removal. So what I want you to think about, think of like a submarine. A submarine goes underneath the water, right? So subduction zone means that it goes underneath the other plate. Now, subduction zones are important because they end up creating two major things. They create volcanoes, they create trenches. All right, so y'all know what volcanoes are. You got all the lava and all that stuff, right? All right, so when an oceanic plate and a continental plate, so nice and thick continental plate, real thin but dense oceanic plate. So as these two collide, one of them gets pulled down underneath the other. The oceanic plate is always going to get pulled down underneath. Well, as it goes underneath, it ends up melting, right? Okay? It melts as it enters into the magma. So that means you now have magma right below the Earth's surface. All right? So that gives you this pocket of magma and lava, or it's not lava yet, this pocket of magma right close to the surface of the planet. So then if enough pressure builds up, you end up with an eruption. And so that's how you'll get these volcanic mountain ranges like what you can find in Chile and Peru. All right. So in Chile and Peru in South America, the Nazca plate is getting pulled underneath the South American plate. And the Andes Mountains are this very thin line of mountains that are very tall. And they're just like the Himalayas, they're building up still. But because of that, you end up with volcanoes that erupt constantly because that Nazca plate is being subducted underneath the South American plate. Now, oftentimes when that occurs, so as we were showing, you've got your continental plate, you have your oceanic plate, and I want you to notice like where my knuckles are. Do you see that V that forms there? That V is in the form of a trench. So a trench, I want you to think of like in Finding Nemo when they were swimming down into the deep, dark area. The Marianas Trench was formed because of subduction. Subduction is that trench is formed because that plate is getting pulled underneath it, and it ends up creating a deep V where the subducting plate is getting pulled underneath it. So that's why subduction zones are always going to create volcanoes, and they will always create trenches. All right. Now, if you have two oceanic plates that meet up, the older, denser plate is going to subduct underneath. Now, the reason why that's important is because that's what's happening to the Pacific plate right now. As the Pacific plate is subducted, it's being subducted on 3 of the 4 sides of it. The reason why that's interesting is that means that the Pacific plate is steadily getting smaller. So the Pacific Ocean is getting smaller, whereas the Atlantic Ocean is getting bigger. So as you see, that's why our planet has not continued to get bigger and bigger and bigger, because on one side of the planet, it is expanding, but on the other side of the planet, it's shrinking. So it evens itself out. So our planet is approximately the same size. So when those two oceanic plates collide, the older and denser plate is going to subduct, creating another deep ocean trench. But in this case, instead of creating a volcanic mountain range, it's going to create a volcanic island arc, like Japan. Japan itself was created from a volcanic island arch due to the subduction of the Pacific plate. The Aleutian Islands up in Alaska are also formed in this way because they are part of the Ring of Fire. There's a huge ring of fire all the way around 3/4 of the Pacific Ocean. And the reason why that is because, like I said, the Pacific Ocean is being subducted underneath the surrounding continental plates. Now, what happens if you have 2 continents collide? Ba-bam! All right. So you've got 2 continents colliding. Well, they're the same density. So what are they going to do? They're going to start pushing and forming upwards and upwards and upwards. And that right there is how we have the Himalayan mountains. So when 2 continental plates collide, both plates are equally dense. So the plates slam into one another and the mountains form from the uplifted rock. This is how the world's largest mountains, the Himalayas, have formed Mount Everest, and it continues to get taller every day. Mount Everest grows about 2 centimeters a year, all right, which doesn't sound like much, but let me put it in your terms. It gets about an inch taller every year. So for those of you who are older than 12, that means that in your lifetime, Mount Everest has grown over a foot. All right, so how does plate tectonics change the Earth at slow and fast intervals? The map shows Earth's tectonic plate boundaries. These arrows show the direction that each plate moves. The length of the arrow shows the approximate speed that that plate moves. So if it's a long arrow, it's moving very fast. If it's a short arrow, it's moving very slow. So we've talked about the Nazca plate. See how the Nazca plate is moving pretty fast into the South American plate, all right? The African plate is moving at a good steady pace. And Eurasia is not moving very quickly at all, okay? So I want y'all to notice the length of the arrows. So now take a moment, color the Earth's tectonic plates, and answer the questions. So you're going to watch this video, which is the Plate Tectonics Brain Pop. I'll have that as an ed puzzle for y'all. And that's going to move into your Sum It Up. I hope that plate tectonics makes more sense to you now. Please feel free to reach out and ask questions if you have any. Thanks. Have a great day.